It's wonderful to be here at DataMass. This is the first time I've spoken in a U-boat factory, but as they say, there's a first time for everything. I'm Bill Wilson. I head up the data and analytics capability at Kainos. The primary reason why I'm here at DataMass is actually recruitment. So I'm on the lookout for data engineers who are after some interesting projects to work on and some new exciting challenges. So if that's you, I really want to speak to you. This whole issue of data ethics really came to my attention through a recruitment situation. So I had somebody apply for a data scientist role, and they asked me, what is Kainos' data ethics policy? But I guess we wouldn't really be speaking about this today if it wasn't for the Facebook and Cambridge Analytica scandal that happened earlier in this year. And I can just about see everyone in the room. So I wonder if you could put up your hand if you've stopped using Facebook in the aftermath of that scandal. Anyone stopped using Facebook? No one at all? Okay. Anyone not on Facebook in the first place? Yeah, a few. Okay. We asked this question at a data conference in Scotland recently, and it was amazing how many data professionals basically didn't trust Facebook with their data in the first place. But we'll talk a bit more about Facebook later. So here's a story you might not have seen, though. It's about an organization called UCAS in the UK. So there isn't really an equivalent in Poland, but basically what UCAS does is allow students to submit one application to university, and then those applications are then forwarded on to 5 or 6 different institutions. So it's a really helpful kind of scheme for people who want to apply to university. One of the services that UCAS provides centrally is a kind of risk and fraud rating service. So they are looking for people who are making fraudulent applications to university. For example, people who are just trying to get a student visa to work in the United Kingdom. And of course, there's a algorithm behind this risk rating system. And it's worth knowing that a few years ago, there was a actual real problem, genuine problem of people from West African origin applying for student visas simply to come to the UK to work. Now, what did the newspapers find? Earlier this year, the newspapers, not just the Independent, found that black students were 22 times more likely to be targeted for having their applications checked for fraud compared with white students. Even though the actual levels of fraud between both groups turned out to be the same. Now, this is quite embarrassing for UCAS because one of its aims is to broaden access to the UK higher education sector. So, for example, black people are very much underrepresented in UK universities. And we know that a lot of the work they're doing in data science is for the public good to try and broaden access to higher education and perhaps level out this playing field, okay? So data science for public good. So we know that when used correctly, these algorithms can perhaps eliminate or reduce the effects of human bias. So what went wrong in this case? UCAS haven't revealed the full details, but what we do know is that they trained their algorithm on some very old data. I don't think I can tell you quite how old that was, but it was very old, let's put it that way. And so now they've changed their algorithm and they're just looking at the last 6 years worth of data, and we should expect the problem will go away. The obvious lesson here is to be careful on the data you train your algorithm on. But I guess for the data scientists in the room here, and I know there are a few, you can understand how that kind of error could have happened. Now, each incident like this undermines public confidence in data science as a whole and makes it harder for us as data professionals to get hold of the data that we need to develop the algorithms as the future. And that's why I'm bringing this issue to DataMass today. You see, the rest of the sessions at this conference have a very technical outlook. And as a data architect working in Kainos, we tend to work at the forefront of some of these types of technologies. It's really exciting to come to a conference like DataMass and see the new developments in software and techniques. That last presentation was absolutely fascinating, for example. But as professionals in this area, we have a responsibility to use these tools properly and ethically. You see, who else could know about how this problem occurred, apart from the data scientists who developed the algorithm? These answers aren't going to come from the people at the top of major institutions and government departments. They're going to come from people in this room. And of course, as individuals in society, we may become more and more influenced and steered by and having to trust data scientists and data curators for control of the news agenda, our consumption habits, our social interactions. So, as they say in Spider-Man, with great power comes great responsibility. So, I guess one of the problems with talking about ethics is what happens if my ethics aren't the same as yours? Let's just think back to that UCAS example for a second. Imagine the scenario in which the algorithm was actually correct. There was no problem in the way it had been trained, and it predicted fraud very effectively, but it still discriminated against black people. Now, should we carry on using that algorithm? We could debate that all afternoon. So rather than do that, and rather than talk about moral absolutes as a technology conference, I'm going to think about two different areas. And the first one is what I call unintended consequences. So what I'm going to argue here is that we should understand more the consequences of the actions we take, and then they won't be unintended, or at least they'll be informed. And the second category of things is what I've called decisions that blow up in your face. So thinking about how would this activity go down in the press, how would this look in front of the newspapers, what's the impact on trust? Now, Facebook, for example, their share price plummeted in the aftermath of the scandal. What's quite interesting is they haven't lost actually that many users, but trust has been eroded. And of course, they may face further legal action around the world. But I don't want to talk about legal frameworks today or regulations like GDPR, or at least not the regulations that exist today. I want to go beyond that and think about how we lead on data trust. So we have these two types of things that can go wrong: unintended consequences and decisions that blow up in your face. And we're going to look at a few examples of each, and then to make this a helpful talk, I'm going to think about some of the ways we can avoid these kind of problems happening. So there's no technical content in this talk. If you're looking for that, next door they're talking about Cloudera shared data experience, which is quite a cool technology. So feel free to leave now. Right, so let's look at the first one. This is the city of Boston, and you can see the various districts, all of them color blue apart from the one in the middle, which is called Roxbury. And the blue areas represent the districts of Boston, which Amazon had rolled out its same-day delivery service as of April 2016. And Roxbury is a predominantly black area of Boston. The rest of the areas are predominantly white people living there. So Amazon obviously did some thinking, wrote some algorithms to work out where they were going to roll out their same-day delivery service. So was that algorithm racist? Well, definitely not. The algorithm will have just been looking at various parameters. One would have been distance from depot, but another would have been the number of, say, Amazon Prime customers living in each area. And so naturally, this is the kind of result you get. But I guess the problem here is that those kind of demographic patterns then force a continuation of a kind of discrimination problem that's been going on for years in Boston, and there are a few other examples as well. Now, Amazon moved very quickly to close this particular gap. Actually, before we move on, there's one other which is a bit similar. Anyone who's played Pokemon Go, I'm not one of those people, but apparently there's things called Pokestops in Pokemon Go and Pokemon gyms. And again, you can see a very interesting distribution of those when you look at kind of predominantly white and predominantly black areas in the United States. And again, that's probably just reflective of the demographic of the people playing those kind of games. But again, if you're living in a predominantly black area, you feel like I'm being discriminated against here. Where's all the Pokestops near me? If you don't know what a Pokestop is, I wouldn't worry, you haven't missed much. Okay, so we talked about a couple of examples involving race. This next example involves health. And we're talking about some of the early days of neural network type models. Piers very usefully this morning said neural networks kind of started in the 60s. But I guess things kind of really started to get going in the kind of 90s. That's certainly when I started getting really interested in neural networks. And this neural network, the experiment, or the hypothesis, the question it was trying to answer, as Piers reminded us this morning, was how can we prioritize the admission of patients with pneumonia into hospital? So a number of people with pneumonia turning up at a hospital, who should be seen first? And one of the results of the model was that it deprioritized people with asthma. So people with pneumonia and asthma, the model put them to the bottom of the list, lowest priority, which was both surprising and also very dangerous, because that combination of conditions, pneumonia and asthma, is life-threatening. So the researchers wondered what had gone on here until they realized the underlying source data. See, what happens if you go to hospital and you have that combination of conditions, pneumonia and asthma, the doctors will put you right to the front of the queue, you'll get the very best care, and lo and behold, those people actually have the highest survival rates. So ironically then, the algorithm was putting them to the bottom of the queue. Okay, now let's think about the effect of data ethics in the criminal justice system. Again, Piers touched on this very briefly in his talk. Here's another way in which algorithms can have a very significant impact on people's lives. Now, like many states in the United States, Wisconsin uses an algorithm to help predict the chances of somebody reoffending once they've committed a particular crime. And the idea is that's used to kind of determine jail sentences and inform some aspects of the criminal justice system. And this rather dodgy-looking guy here is called Eric Loomis, and he was convicted in 2013 of taking a car without the owner's consent and of fleeing from a police officer. Now, those two crimes don't actually carry a prison sentence necessarily, but he was given quite a high score on this algorithm. The algorithm's called Compass. It's got a 10-point scale. He was given quite a high score, and as a result, the judge gave him a 6-year prison sentence that he's still serving. Now, Eric Loomis appealed against that decision on the basis that the algorithm was opaque to him. It wasn't clear what factors had been considered. It wasn't clear whether his own background had been taken into consideration. Now, his appeal failed. I guess part of the point was that there was a human in the loop, so that the algorithm didn't produce a sentence. The judge looked at the output of the algorithm and then made his or her own mind up. But I guess people in this room know there's an effect of the authority of algorithms. So sometimes people say, well, the computer said that, it must be right. So the question is, could there be unintended consequences from those types of algorithms? Can we trust the Compass algorithm? What evidence is it based on? We'll come back to this algorithm a little bit later. So one more example. Some of you may know this one. Microsoft released a chatbot a couple of years ago now called Tay. Tay was trained with the personality of a 19-year-old teenager. And Tay was set free on Twitter to interact with the various users there. And within 16 hours, she turned into a massive racist with some very extreme sexual tastes as well. This was one of the treats quite early on. You can see she's becoming a bit right-wing already. I won't show you the rest because they're filthy and repellent. So basically, there are loads of ways in which algorithms can go wrong, and you end up with unintended consequences. There's just a few examples. Now we're going to have a look at these ones over here of companies who made some deliberate decisions, and either they misjudged public opinion or they thought they'd get away with it. Now, many of you will know the backstory of Facebook and Cambridge Analytica. For those of you who don't, in brief, Cambridge Analytica were able to get hold of the Facebook data of 87 million Facebook users off the back of a personality survey done by about 250,000 people. And the reason for that was that at the time, the Facebook sharing, data sharing policies allowed if you had an application on Facebook and somebody was using it, you could get at that person's friends' data as well as that individual. Okay, so many people would consider that to be pretty unethical, and Facebook have since changed that policy. Now, at the time, Facebook were trying to encourage more developers to come onto their platform, and the idea of getting some friends' data was very enticing. It was an incentive. Now, whether Facebook, Cambridge Analytica later used that information to influence the US presidential election or the Brexit vote in the United Kingdom, that issue is still being decided by lawyers, so there's only so far I can go with that. But I think what we do know is the power of psychological profiling combined with targeting advertising, it can be extremely effective, and I think it's fair to call this weaponizing information. Now, Cambridge Analytica's defense was that they were only doing what lots of other companies are already doing. But public opinion disagreed, and all their customers left, and now they've gone bankrupt. Let's look at another example. This one is in the City of London. And this company, Renew London, decided to roll out a load of what they call smart bins, okay? So these smart bins are equipped with a big screen and passive Wi-Fi captures. So basically, they're profiling the MAC addresses of people's phones as they walk past. And the idea was that if you were, say, a retail store or a coffee shop or something like that, you could install some similar technology on your premises and understand where users had come from, where the sort of roots of your customers. You could get a bit sneaky and put a Wi-Fi capture outside the toilet so you can sort of profile what gender you've got. And if you have given away free Wi-Fi on your premises, you could correlate MAC addresses with personal data and start to build up quite an interesting picture of where your customers are walking around the city. And I guess the idea was a bit like that film Minority Report. Do you remember the point where Tom Cruise is walking along and there's some iris recognition and then it displays an advert just for him? So you could do something slightly similar. See your potential customer walking up to the bin and the screen says, why don't you come in for a coffee half price today, something like that, right? So you can imagine how the business model, people were getting excited about it. But the public disagreed. There was a big backlash in London. The bins were taken down, and this company is also out of business now. So we've seen some examples of unintended consequences and deliberate decisions that blow up in your face. And we're going to look at some examples of how to avoid that now. Now, some commentators think that there's actually an opportunity to what we call differentiate on trust. So could your business differentiate its products and services based on improving public trust? How do governments maintain trust between citizens and government departments about how personal data is used, how automated decisions are made? Now, of course, this isn't all about personal data. If you remember the Amazon example, there wasn't any personal data involved, but people still felt discriminated against. So I'm going to talk a little bit about something called the Data Ethics Canvas from the Open Data Institute. I found this quite helpful in kind of shaping Kainos's own data ethics policy, but also working with customers on these kind of issues as well. And as you can see, there's lots of different boxes here, lots of different considerations. Some of them aren't very technical at all, they're kind of procedural. So we're just going to dip into a couple of areas here this morning. But before I do, one thing I would recommend is having your own data ethics policy, because that provides a yardstick that you can go back to and avoids a kind of drifting ethical stance for your organization. So I mentioned I've been working on the Kainos data ethics policy. So that policy says things like, we won't work with political profiling organizations, and it asks some test questions like, does this work make me feel proud to work for Kainos? I was speaking to Microsoft a couple of days ago about their ethics policy, and they've obviously had one a lot longer than Kainos have. And they've actually got a whole SharePoint site of proposals that have come to Microsoft that they've then rejected on ethical grounds. So that provides an interesting kind of backlog of decisions you've made. One of them that I can talk about, one company approached Microsoft to see if they could monetize the Cortana data. So for those of you who aren't Microsoft users, Cortana is like the Siri of Microsoft. And the idea was you would ask for a particular service, and then this company wanted Microsoft to let them know who'd asked for that service so they could do some push advertising. Now, I guess the point is, if that ever came to light, the kind of Cortana business model would disintegrate. Okay, so I think we're going to dig into a few of these areas now. The first one is around minimizing negative impact. So the canvas asks questions like, could you monitor the effect of potential negative impacts of the work you're doing? Well, we can go back to the Compass algorithm in Wisconsin. And fortunately, the Washington Post have done just that in this quite nice graphic. And it's looking at a particular aspect of that algorithm to basically work out whether it discriminates against black people. You can see perhaps a bit of a pattern here. So what they've done, I think I mentioned the Compass algorithm is a 10-point scale. So the Washington Post have simplified that into kind of low or medium and high. And as you can see, they've split this graph into black and white people. And then you can see the numbers of people who reoffended versus didn't reoffend. So the first thing we can see is that the algorithm is somewhat useful. So it tended to place people in a medium or high risk category where they did in fact later go on to reoffend more often. In fact, the algorithm as a whole is about 65 to 70% accurate. So it's worth it. Worth doing something. Now, of course, it's worth saying race was not a factor in this algorithm. I think that would be a fairly stupid thing to do from the outset, but lots of other factors that were tend to be highly correlated with race, hence some of these results. Okay, and we can also see that the same proportions, roughly speaking, of black and white people went on to reoffend versus didn't reoffend. So the same, very roughly speaking, the split between the light blue and the dark blue is similar, okay? So on that basis, the algorithm is fair. However, significantly more numbers of black people were placed in the medium and high category who didn't later go on to reoffend compared with white people. So it's basically this section of the graph just here. So on that basis, is it in fact fair? So we're not going to make an ethical judgment about that this morning. But the point is, judges and others involved in the US criminal justice system can now use this kind of information and research to make some more informed decisions. Now, before we leave this algorithm, it's worth mentioning that the state of Pennsylvania has taken a different approach. So they've decided to develop their algorithm in the full light of public scrutiny. So Compass is actually owned by a private company, so it's got there's IPR restrictions on it. And of course, like a lot of machine learning models, sometimes it's hard to say why the model has come up with that particular, it's come up with that particular score. You can't get the machine learning to explain itself. Now, Pennsylvania will have the same problem, but they've done a lot of consultation around the factors that should be included in the algorithm. And one of the things that changed during that consultation process was they started off, one of the input parameters would be the number of times you've been arrested. But that was later changed to the number of times you've been arrested and charged, because there was a disproportionate number of black people who would be arrested and then not later charged. So there are ways of kind of readjusting the scales a little bit. Okay, so now we're going to look for, one more thing. So given that we know some of our algorithms can be subject to these kind of biases, we can now test to see whether they are. And a friend of mine called Adam Smith at the Piccadilly Group has a load of tools and actually a team dedicated to doing this kind of thing, testing algorithms to see whether they discriminate on racial or sexual grounds. Okay, let's look at data anonymization now. Now, data anonymization is another technique that can minimize the impact, negative impacts. But you have to be careful how the data sets might get de-identified. So in the mid-1990s, for some reason all these examples are from America, but the state of Massachusetts bought some healthcare for all of its employees. And in the process of doing that, they deliberately released a data set about people's hospital stays and medications, prescriptions, that kind of thing. And at the time, the governor of Massachusetts, this guy, Bill Weld, said, it's fine, all the personal data has been removed, you can't identify people. But unfortunately, that data set contained over 100 identifiers in it, or bits of information you could use to identify people. This lady here, Latanya Sweeney, who was a graduate student at the time, she used zip code, date of birth, and gender to find the governor's own medical record and published it online. Now, that example seems a bit trivial now, but it's surprisingly difficult to fully anonymize data. So, because of the problem of quasi-identifiers that exist in the data. Let me give you another example from much later on. In 2013, the New York Taxi and Limousine Commission released a data set of all taxi rides taken in New York during that year. And obviously, they took steps to de-identify the data, so they hashed the vehicle license plates. But unfortunately, when they did that, they didn't quite do it properly. So the range of vehicle license plates was relatively small, the range of possibilities, and they didn't use a salt when they did that hashing. So the net result was it was possible to use a rainbow attack to de-identify those vehicle license plates. It only took somebody about 2 hours to do that. And then later, somebody else used that information to cross-check with pictures of celebrities getting out of taxis and started tracking the celebrities around New York, which is quite fun. Somebody else used the same information to find regular customers of notorious nightclubs, which is quite embarrassing. Now, Apple are experimenting with some technology that offers some privacy guarantees, which I think is worth mentioning here. Now, I wouldn't defend everything Apple does, but in the area of privacy, they are trying to take a lead and differentiate themselves a bit on trust. So, for example, Apple never share personal data with third parties and other organizations. Sometimes they're forced to disclose data by people like the National Security Agency in the United States. But if you go onto apple.com/privacy, you can read all about that process, how many requests they've had, basically as much information as Apple are able to release about that kind of process, which makes quite interesting reading. But let's talk about the particular technique they're using for data anonymization. Now, Apple wants to collect information about how its devices are used so they can improve them going forward. And this interesting bar chart, which doesn't got a scale on, basically represents the popularity of certain emojis amongst US English speakers. It was gathered using a technique called differential privacy. So differential privacy is a whole talk in its own right. But essentially what differential privacy does, it's introduced some noise into the data so that it becomes possible to hide. You kind of have some plausible deniability about whether that data really relates to you. So let me be specific and explain how this works. So on your Apple device, Apple is sending, if you agree, the device is sending this kind of information to Apple. Now and again, at a kind of random rate, it will send the wrong information, okay? So if this data set ever became reassociated with you, you could have plausible deniability and say, well, in this case, the device sent the wrong information, so this wasn't the emoji I used in this example. But when you aggregate that information, when Apple bring it all together, then that noise kind of disappears from the data set. So this isn't a wholly accurate graph, but it's perfectly good enough for what Apple need to do. I don't know, placing emojis on the right part of the keyboard. That's the kind of thing that excites them. So hopefully you see it's a really good use of data privacy. Okay, we're going to look at another area now, which is engaging with people. So in order to avoid some of these kind of public relations disasters, you've got no choice but to actually talk to the public about how you intend to use data. Now, I'm working with an organisation called the Co-op in the United Kingdom. The Co-op do lots of different things from retail through to funerals, but they're owned by their membership, and they're very keen to make sure that the members are happy with the way Co-op is using their data. And they've done a lot of public consultation, and fortunately for me, they've blogged about it, so I can talk to you about it this morning. One of the things I found from this piece of research is that Co-op members don't speak with one voice about these kind of issues. So there's kind of different attitudes to how much Co-op should use people's data, perhaps to personalize things for them, give them offers and so on. So what that means for Co-op is when it comes to kind of privacy policies, they need to allow Co-op members to have lots of different options so they can express their different preferences. Okay. Let's look at one other area probably. So this is areas about how we're using your data and your reasons for it. So it seems like an obvious recommendation to suggest that your privacy statement on your website should be easy to read, easy to understand. But the Facebook privacy statement in 2010 was longer than the US Constitution. Now, I guess part of the problem is, for us as data professionals, explaining to a member of the public how we want to use their data can be quite complicated. How do you explain that in simple terms? Well, there are no great examples of that at the moment. But one thing that is quite useful is called just-in-time privacy. So what happens there is as you're providing personal information to an organization through a mobile app or on a website, there's a little pop-up that says why they want that information and how they want to use it. Now, some websites are using something called cookie walls to get around some of this legislation. So you'll have experienced cookie walls. It's where there's a kind of big banner right across the screen, and unless you accept their cookies, and in particular third-party cookies, you can't use their website. So anyone trying that technique, though, needs to be careful because the European data protection regulators want to crack down on that. In other words, denying people services because you don't agree to third-party cookies. And in fact, UCAS, who are the organisation that we talked about at the start, they got in trouble earlier this year for something similar. So in the terms and conditions as people signed up for UCAS, unless you gave UCAS permission to reuse your data for marketing, students were left with the impression that they would miss out on important information about their higher education choices. So they kind of felt obliged to share their data. So UCAS have had to now change that. Another possible outcome might be kind of more paid for services, so it becomes clearer the transaction you're taking. So you either give away some of your personal data in return for free services, or you might choose to pay for it. So there might in future be a paid for Facebook which is a little bit like rich people have that option today. If they want an anonymous bank account, they go to Switzerland. So it could be an interesting kind of rich-poor divide there. Okay, going to look at limitations of data sources now. So we talked about a few examples of where this can go wrong. Now, sort of data sets that weren't properly understood, but the canvas asks us to think about gaps and omissions in our data sets as well. So I actually have a psychology degree, and in psychology we learn how to recognize bias in psychology experiments and adjust for it, because it's absolutely pervasive. Unfortunately, trying to study people is a bit tricky. So the question is, do we teach our data scientists some of those same techniques? Another consideration to think about is, where's this data come from? So as we increasingly work with data sets that have been aggregated from across the web, you're really dependent on the privacy policies of the sites where that information has been collected to know whether you're working with a data set that's ethical to use. And of course, we also use fragments of algorithms that have been developed by others. Again, what data sets have they been trained on? So I don't think there are any easy answers on that one, but something to be aware of. And lastly, because we're getting towards the end of our time now, existing ethical frameworks. So as machine learning becomes more effective and more self-governing, it's going to become increasingly important to provide ethical frameworks for the artificial intelligence to run inside. Now, in case you think that sounds a little bit like I, Robot, that film, this stuff is already happening in the sphere of autonomous vehicles. So if you're a manufacturer of autonomous vehicles in the United States, you actually have to take account of ethical decisions that your vehicle might need to make. So here's an example. Well, I suppose the way that those companies are tackling that problem is they are surveying the public with lots of different scenarios. What do you think the car should do in this scenario? What do you think the car should do in this scenario? And so far, what they've concluded is that the car should kill the fewest number of people, okay? So maybe that's not an extraordinary conclusion, but that doesn't help you in lots of other edge cases. So imagine this scenario, 5 years' time, there are autonomous vehicles running down the roads of Gdańsk, and the vehicle is running down the road, and 3 drunk men stagger into the street. It could happen. There are lots of really good bars in Gdańsk. But the vehicle is forced to swerve to avoid hitting them, and hits 2 children standing on the pavement and kills them. So in that scenario, the software has done what it wants, but a lot of people feel perhaps it wouldn't have made an ethical decision. So I think we'll be talking about some of these kind of issues at DataMass 2020 probably. But as I close, let me leave you with a message of hope. You see, the application of data ethics to the algorithms and to our work is going to be a journey for everyone in our industry. There are lots of considerations to think about along the way. Hopefully I've given you some food for thought this morning. But I think the real prize is the value of data exploitation in the service of everyone. Thank you very much.